Hello. We are covering 6.5 dividing polynomials here. And then the next section, 6.6 synthetic division, that is just going to be another method for dividing polynomials. Okay. And then that will wrap up chapter 6. So take notes. 6.5 dividing polynomials. So again, make sure you are spending no more than 3 to 4 days on each homework set, even if you have a week to do them. Staying on that sort of a pace, 3 to 4 days on each set, will help you to stay on target with completing your assignments and not fall behind. Okay? All right, so dividing polynomials. So let's just kind of recall long division. And if you learn long division in a different country, that's fine. I'm not really sure how it would work out with the rationals here, but let's have a look. All right, so maybe you learned how to do long division like this. Suppose that you were dividing 5 into this number. Okay. So what we do here is we try to figure out 5 times what. Okay, 5 times what equals this number here, or close to it, okay, without going over. Okay, so 5 doesn't go into 12 evenly, but it's pretty close when I multiply it by 2, right? 5 times 2, okay? And then what I do next is I multiply, right? I multiply these numbers, and I put the answer underneath here. Okay, so this process that we just did right here is going to be similar to the process that we're going to be doing when we divide polynomials. We try to figure out what times what, 5 times what will give us this here, or close to it, and then we put the answer here. We multiply, and we put the answer here, and then we subtract. Okay, and then we bring down. Okay, so this whole process here is going to be very similar. You know what? Let me go ahead and I'm going to make this a little shorter so we can cut the process down. Let's just go up to there. Okay, and then we continue. We go ahead and again, we ask ourselves 5 times what will give us 23, or close to it. That would be 4. 5 times 4, that's 20. And I put the answer underneath here, and I subtract it. And then I bring down. And again, I ask myself 5 times what is 34, or close to it. So that would be 6. And 5 times 6 is 30. And I put the answer down here, and I subtract it. Okay. Now, this is my remainder. Okay. And so what we're going to do with the remainders, with the polynomials, is the same thing that we do here. We're going to go ahead and take that remainder, 4, and put it over the thing that we divided by, which is 5. So here the answer is 246 and 4/5. Okay. All right. So now with polynomials, let's have a look. Okay, so now what we're doing here is we want to divide these two polynomials. Suppose I have this one here, 3, 3x cubed minus 28 minus 3x plus 2x squared divided by x minus 2. Okay, so what we're going to do here is we are going to, first of all, we want to make sure that the polynomials, both of them, this one here and this one here, we want to make sure that both of them are written in descending order. So rewrite polynomials in descending order. Okay. And then the other thing we want to do is if we have any missing terms, we want to use 0. Okay. So for missing terms, use 0. Okay, it's use the 0 placeholder. Okay, so let's have a look. So I'm going to go ahead and this here is not in descending order. We start off with x cubed, and then so the next term should be x squared, which is way over here. Okay, so I'm going to fix this so that it's in order. All right, so it's 3x cubed, and then plus 2x squared, and then the x term comes next, and then the minus 28. Okay, so that's what we mean. That's what we mean by writing it in descending order. And then we're going to be dividing by x minus 2. Okay, we don't have anything missing, so we don't have to use a placeholder. So we would use a placeholder if, let's say, this polynomial, instead of having this, if we had 3x cubed minus 3x minus 28, if we had that, then I would put a placeholder here, 0x squared. Okay. Okay, so once we have everything in place, then we're going to go ahead and write it like this. Okay, and then we begin our long division. Okay, now when we do our long division, we try to figure out what to multiply with up here. We kind of ignore the polynomial except for the leading term. So we use this here, x. Okay, so ignore the minus 2. And so we're using this x, and we're trying to figure out x times what is 3x cubed. Okay, so that would be 3x squared, right? x times 3x squared would give me 3x cubed. Okay, all right, so once we have a number up here, then we go ahead and multiply just like with the problem up above with the 5. So when we try to figure out this number, we ignore the minus 2. But now when we multiply this entire polynomial here. Okay, so 3x squared times x is 3x cubed, and 3x squared times negative 2 is negative 6x squared. Okay, so you see here these match, right? These are both x squared. So that's why it becomes important that they are in order. And it's important to use a placeholder if you're missing any terms. So if we didn't have an x squared term, we would need a 0x squared. That way the terms all line up. Okay. And then when we put our answer down here, we subtract it. 3x cubed minus 3x cubed is 0. And then over here, this is 2x squared minus negative. Minus negative becomes positive. So that becomes 8x squared. And I'm going to bring this down. Okay. And then I start over again, but I just use the x. I ignore the minus 2, and I try to figure out x times what will give me 8x squared. So x times what will give me 8x squared. Okay. And that would be positive 8x. Right? X times 8x is 8x squared. All right, so when you put a term up here, then you go ahead and distribute it to the entire polynomial here. Don't ignore the minus 2 now. So 8x times x is 8x squared. 8x times negative 2 is negative 16x. And then we're going to subtract all of this. Okay, 8x squared minus 8x squared cancels. negative 3x minus negative 16x. So that becomes plus 16x, and negative 3x is 13x. I'm going to bring this down, minus 28. And then again, I try to figure out, ignore the minus 2, x times what will give me 13x, and that would be 13. And now we're going to go ahead and distribute this 13 times all of this. So 13 times x is 13x. 13 times negative 2 is negative 26. And then we subtract this. They cancel out. This becomes negative 28 minus negative 26. So that's negative 28 plus 26. And that gives us negative 2. That's our remainder. Okay. So this is our remainder. So when we bring it up here, right, it's going to say minus 2 over the thing we're dividing by. Okay, so our final answer is 3x squared plus 8x plus 13 minus 2 over x minus 2. Okay, all right. So you can see the similarities to regular division with numbers. Okay, all right, let's go ahead and do another example. All right, so let's do this one. Negative 10x plus 12x cubed plus x squared minus 3 divided by 1 plus 3x. Okay, so we want to put these in descending order. So this is going to be 12x cubed plus x squared minus 10x minus 3 divided by 3x plus 1. Do I need any placeholders? 3, 2, 1, 0. Okay, no placeholders needed. Okay, so I can go ahead and begin. 3x plus 1, 12x cubed plus x squared minus 10x minus 3. Okay, ignore the 1. 3x times what will give me 12x cubed? That would be 4x squared. Now distribute 4x squared to all of this, and I get 12x cubed plus 4x squared. If your terms don't end up lining up, it's because you either, number one, you didn't rewrite them in descending order, or number two, you forgot to put a placeholder somewhere where there's a term that's missing. Okay, so whenever you put terms here to subtract, all of the terms should match up. Like you should have x cubes here, x squares here, no x here. Okay, all right, let's go ahead and do the subtraction. X minus 4x squared, x squared minus 4x squared is negative 3x squared. Bring down the minus 10x and start all over again. 3x times what is negative 3x squared? That would be negative x. Okay, now distribute negative x. Make sure it's negative x that you're distributing to both of these. Negative x times 3x is negative 3x squared. Negative x times 1 is negative x. And let's go ahead and subtract these. So these cancel out. And that becomes negative 10x minus negative x. So negative 10x plus x is negative 9x. And I'll bring this down. Okay. And then 3x times what will give me negative 9x? That would be negative 3. Now distribute. Negative 3 times 3 is negative 9x. Negative 3 times 1 is negative 3. And when I subtract this, we get 0 for a remainder. Okay, so then our final answer would be 4x squared minus x minus 3. Okay, this tells me that 3x plus 1 is a factor of this. So if we were to factor this polynomial in here, 3x plus 1 would be one of the factors because we got 0 remainder. All right, let's do another one. Let's do one where we need to use the placeholder, okay? Suppose I have this, 64x cubed plus 1 divided by 4x plus 1, okay? All right, so clearly we're missing a bunch of terms. Here, we're missing the x squared, and we're missing the 0x. So when I rewrite this, it's going to be 64x cubed, and then I use a placeholder for the x squared that's missing, and I use a 0x for the x term that's missing, and then I have the plus 1. And nothing is out of order here, nothing is missing. All right, so now I can go ahead and begin. I have 4x plus 1, and I'm dividing that into 64x cubed plus 0x squared plus 0x plus 1. Okay, so I begin here, again, ignoring the plus 1 here. 4x times what will give me 64x cubed. Okay, so that would be 4 times 16x squared. And then now distributing to all of it, 16x squared times both of these will give me 64x cubed plus 16x squared. Okay, subtract. These cancel out. I'm left with negative 16x squared. So you see here, we use the placeholder, and we see here that the x squareds do match up. If you didn't put these here, then the 1 would have been here, and they don't match, right? Okay, so that's why we have them there. All right, bringing down the plus 0x. And then again, starting over here, 4x times what is negative 16x squared? So that's negative 4x. Okay, and then distribute that. Negative 4x times both of these. That's negative 16x squared. And negative 4x times 1 is negative 4x. Subtract. These cancel out, and this becomes positive 4x. I guess we don't have to put the positive. 4x, and bring down the plus 1. And then 4x times 1 will give me 4x. So distribute this, 1 times 4x, 1 times 1. And we actually get 4x plus 1. And when we subtract, everything cancels. And we get 0 remainder again. Okay, so the answer here would be 16x squared minus 4x plus 1. Okay, and we'll do one more example, and that'll be it. Okay, let's take a look here. Suppose that we have this one, negative 17x squared plus 5x plus x to the 4th plus 2 divided by x squared minus 1 plus 4x. Okay, so let's go ahead and rewrite these so that they're in order. I see here we're missing x cubed, so I'll use the 0 placeholder. Okay, so starting with x to the 4th, and then 0 placeholder for the missing x cubed, and then the x squared goes next, and then positive 5x, and then the 2. And over here, x squared goes first, and then the plus 4x, and then the 1, minus 1. Okay. So let's go ahead and begin. X squared plus 4x minus 1, and this long polynomial here, x to the 4th plus 0x cubed minus 17x squared plus 5x plus 2. Okay, so it starts the same way. Okay, you just have to ignore all of this. Just focus on that first term, x squared times what to make x to the 4th. So that would be x squared. And then when you place something here, you multiply everything. Don't ignore the 4x minus 1 now. Okay, so now distribute to all of this. So we're going to get a trinomial. X squared times x squared is x to the 4th. X squared times 4x is positive 4x cubed. X squared times negative 1 is negative x squared. Okay, so all I did was x squared times this, x squared times this, x squared times this. Okay. And again, you see how all of these match up. Okay. And if you don't use that 0 placeholder, then they won't match up. So that's why it's very important to have them in order and use 0 placeholders. Okay, so let's go ahead and subtract here. They cancel out. I get negative 4x cubed here. And I get negative 17 plus 1, so that's negative 16x squared. And that'll bring down the plus 5x. And then I start all over again. X squared times what? And that would be x squared times negative 4x. Yeah. Okay, so distribute this, negative 4x times all three of these. So I'm going to get negative 4x cubed. And then over here, negative 4x times this is negative 16x squared. And then over here, negative 4x times this is positive 4x. Okay. And then here, these cancel out. These also cancel out, so that'll be interesting. And then 5 minus 4x is 1x. And then I'll bring down this. Okay, so because these canceled out, we're kind of in an interesting spot here. Let's take a look at the very beginning problem with the 5. Okay, so you know how we know when to stop when we have this remainder, and we know this is a remainder when it's a number that's smaller than 5, right? Because if this were like 8, then I can continue dividing, right? Oh, 5 goes into 8 once. But because it's smaller, we can't continue dividing. This is your remainder, right? Same thing here with polynomials, okay? So what happens is this was a remainder because this is smaller than this. How is it smaller? We compare them, smaller, bigger, by the degree of what's left, the degree of the polynomial, okay? So here, those don't have any. So here, this is smaller than this because this is a degree 2 and this is a degree 1. When you are a smaller degree than the polynomial over here, then this is a remainder. Okay, so we would go ahead and put plus x plus 2 over x squared plus 4x minus 1. Okay, so that would be your answer. So the answer is x squared minus 4x plus x plus 2 all over x squared plus 4x minus 1. Okay. Had these not canceled out, then we would probably be able to continue. Okay. But because these canceled out and these also canceled out, that left us with a polynomial with a smaller degree than this one. Okay. Which makes it the remainder. Okay, so that is it for long division with polynomials. Make sure you email me or text me if you have any questions.